Welcome to the video about the sum of infinite geometric series. First, we're going to talk about convergent versus divergent series. In a convergent series, the sum of the numbers gets closer and closer to one number. So if we look at this first sequence, it has 16, 4, 1, 1/4, and 1/16. So your rate here is 1/4, and your numbers are getting closer and closer to 0. So your sum is going to converge to one number. This second one here, it's -7, 7/2, -7/4, 7/8. So your rate is a -1/2, and the numbers are also getting closer and closer to 0, this time coming from both the negative and positive sides. So for a convergent series, the absolute value of your rate is going to be less than 1. In a divergent series, the infinite sequence of partial sums does not have a finite limit. So this first sequence right here is 2, 6, 18, 54. So your rate is 3. So with each additional number, your sum is going to get larger and larger and will not approach a finite limit. In this second one, you have -8, 12, -18, and 27. Your rate is a -1.5. And your numbers are going to continue to get farther and farther from 0. So there will not be a finite limit for this one either. And the same thing happens with your last sequence, where the rate is -5. The numbers are going to keep getting farther and farther from 0 and will not approach a finite number. So in a divergent series, the absolute value of your rate is greater than 1, which is why it won't have a finite sum. To find the sum of an infinite series, if you have a convergent sequence or series, you can use this formula here. So the sum of an infinite number of terms is equal to your first term over 1 minus your rate, if the absolute value of your rate is less than 1. If the sequence or series diverges, you will not have a finite sum. So here we have an example. The sum of an infinite number of terms of the equation 7 times 1/3 to the n minus 1. So to find your first term, we'll plug in 1 for n. So we have 7 times 1/3 to the 1 minus 1, which is 7 times 1/3 to the 0, which 1/3 to the 0 is 1. So your first term is 7. And your rate is the number here that's being raised to the exponent. So your rate is 1/3. So because your rate is less than 1, we can use our formula here. So the sum of an infinite number of terms is your first term, which we said was 7, over 1 minus our rate, which is 1/3. So we have 7 over 2/3, which will multiply by 3 over 2, which becomes 21 over 2. So that would be your sum of an infinite number of terms in this sequence. So here we have another practice problem. What is the sum to infinity of the following series and sequence? So for this first one here, our rate is 5 over 1, which is 5. And because the absolute value of our rate is greater than 1, we can say that this series is going to diverge. So there is no finite sum. But if we look at the numbers being added, we can see that the numbers are getting larger and larger, and so it's going to diverge to infinity. So that would be your sum. In the second one, we'll find our rate by taking -2 over 11 and dividing that by 1, which is just -2 over 11. So that's our rate. And the absolute value of that rate is less than 1, so we can use our formula. So we'll need to know our first term, which is 1. So the sum to infinity of this sequence is a1, 1 over 1 minus our rate, which is -2 over 11. So that's 1 over 1 plus 2/11, which is 1 over 11/11 plus 2/11, which is 1 over 13/11, which will multiply by 11 over 13. And we'll get that our sum equals 11 over 13. In summary, We can use this equation for the sum to infinity if the absolute value of r is less than 1 and the series converges. If the series diverges and the absolute value of the rate is greater than 1, then we will not be able to find a finite sum. Thank you so much for watching.